Madison Maxey is passionate about working at the intersection of design and engineering to create useful products. She has a hybrid background and studied materials science and engineering at Stanford after completing design work for the FIT Museum, Tommy Hilfiger, and Google Creative Lab. She also held creative technology residences at the School of Visual Arts, Autodesk, and Pratt's BF and DA, where she won the Technology Innovation Award. She is currently using this blended past experience to bring soft, flexible circuits, otherwise known as e-textiles, to scale through her company Lumia. Throughout the course of her work at Lumia, she has developed e-textile prototypes and workshops for companies like North Face, Google, PVH, Flextronics, and Adidas. Her work has built the foundation for 8 granted patents and has led to invited lectures at universities such as Columbia, NYU, and University of Illinois. This work has also earned her a spot in the Smithsonian Museum of American History as part of their Spark Innovation Lab. Welcome, Maddie. It's so nice to finally chat. I think I've been following your work for literally years, but you don't post a lot on social media.
I don't post a lot, but I'm trying to get into it this year. I don't know. I always like following your posts. I feel like it's good to have a cadence in today's world.
Oh, it's way too hard. Sometimes I get into a bit of a rhythm and then I just drop off for months. So, it's hard to do it when you've got a full-time job and all that sort of stuff.
It's a full-time job that's not marketing. I feel like the people who are really good at it are like marketers to their core, and this takes so much effort, but yeah. I think it's worth it.
Yeah, it takes a lot of effort. So thank you for your time today. You actually started in fashion. So I thought it would be super interesting to begin with that because my mom taught me to sew when I was 10 and I was always making stuff. I made my own formal dresses. And then I also kind of moved into tech because I was working in fashion many years ago. So I thought it was so cool that you also made that kind of transition. And I was wondering what interested you in fashion in the first place, and then why did you make the switch to sort of what you're doing now?
You sound really similar. I really loved the making of things. I think that there's something really wonderful about figuring out, the pattern piece shapes and how to line them up and which stitches you should use and which fiber content is best so that the dress you're making won't pucker or wrinkle. Or I really enjoyed that process, but I found that when I started working in the fashion industry, it wasn't as much about that. They weren't having long meetings over fiber content, and I was like, I don't know if this is exactly what I thought it would be where I want to be working. But I think that engineering and product development actually is a lot of that. Our team spends weeks and weeks talking about the materials that we test and which heat settings we use and these very detailed fabrication methods. And I think that's what I liked about making clothing, but isn't actually what most of the fashion industry is focused on. So that's sort of how I ended up finding my way more into engineering. And then I got my degree in material science and engineering. And I still think a lot of the work that we do at Lumia, though, is informed by how the fashion industry works, where it's very much so kind of scrappy, make it work. I remember my internships hauling rolls of fabric to the office.
Yes.
Yeah, I think we bring a little bit of that attitude to our work where it's okay, you can find it on Amazon, let's just buy it. Or, run down the street, let's find something, let's fix it, let's do it, let's make it. So it's a little bit of both.
Yeah. Oh, you just totally triggered this memory of going to the fabric store and the rows and rows of fabric. You can really waste some time there.
And it's also so, I don't know, I really I feel like that's one of the few places that is so all-consuming. It's almost meditative, when you're walking through the rows.
Yeah.
It's nice.
It is. You can totally lose yourself. So you did a really cool work with Zach Posen and Google where you made this color-changing dress. How did you get in, how did you get that job? How did that even come about?
Yeah, absolutely. So that was a light up. I think it was this marketing campaign that Google was doing about sort of how coding or technology can be creative. I ended up getting that project because I was part of a series of videos that they were doing. And then they were like, hey, we want to make this dress. And I think that they, at the time when I did it, I was really young. I think that they talked to some people who were like older and more experienced, but they were too busy. It was like one of those things where I was obviously not the top choice for this, but I still got the opportunity, and I learned a ton from working on that project. And it was also very cool to meet some of these people that I really had idolized, like Zach Posen.
Oh, so it was a light up dress. Sorry, not a color changing one. That was a different dress. That was it Juliana Bass? Was that the color changing?
Yeah, that was color changing.
What I'm so curious about is like, why don't more garments have color changing? I know we're going to get into e-textiles and all that, but yeah, why isn't this more commonplace?
Yeah, I mean, I feel like I have a lot of reasons why it's not commonplace. I mean, this stuff is just so expensive and also generally unnecessary. And also fashion companies don't make a lot of money from making this kind of stuff. Like they will always just Lululemon will always just sell more yoga pants than they would a like $5,000 color changing sweatshirt that is like cool in the press, but in reality nobody will really buy. So I think there's like a lot of business incentives why this stuff doesn't exist on the market. Like the economics, it's not commoditized to the point where the economics make any sense. And I think there's like consumers think it sounds cool, but I think in reality there's not really consumer demand. It's more of like an imagination. I think it's something that captures the imagination, but when push comes to shove and it's like, do you want to buy this battery powered color changing sweatshirt? I mean, I don't even know if I want to buy one.
It seems as though your career in the e-textiles industry kind of really kicked off when you got your Thiel Fellowship. So for those who don't know, the Thiel Fellowship is a $100,000 grant, essentially, would you say, that goes for 2 years, and you get the freedom to create whatever you want. Can you tell us a little bit about that process and that experience? Was that kind of what kicked off your work in this space?
Yeah, I mean, it definitely gave me, so the way that the Thiel Fellowship worked at that time, I think it's changed quite a bit, but it is $100,000 over the course of 2 years. And then that money is also taxed. So it's not actually a ton of, it's like a salary, it's like 2 years of salary for a young person who doesn't need a lot of money.
That's still a lot.
Yeah. When you're 19 or 20, it's awesome because you can go and explore. And so I think that in the sense that it gave me a lot of room to go and explore was very helpful. I met a lot of people, especially I did a residency at Autodesk, and I met all of these very creative and design oriented engineers. And it just felt like all of the things that I thought were wonderful. Like it was very interesting to me. These people like really treated a lot of their work as craft, but had very deep like mechanical engineering or electrical engineering backgrounds. And so I think that sort of helped my work in e-textiles because I saw that there could kind of be these little spaces at the intersection. I think one of the most important things about the Thiel Fellowship is that at that time, I don't know what it's like now. I don't think it helps as much now, but particularly at that time with this fellowship, it was much more possible to raise venture capital. So I think that was one of the most important things for doing work in e-textiles, which is not necessarily cheap work to do. I was able to get access to investment in a way that would have been very hard without the fellowship. Probably not possible without this fellowship.
Yeah, it seems like once you get your foot in the door and you get that support and that endorsement from someone, it's really sort of like a launch pad to, all the ensuing things. Did you get to meet him? Did you get to meet Peter Thiel?
I breakfast with him once, but it's very similar to the like Bill and Melinda Gates Foundation, where it's it's kind of like his name's on it, his money's in it, but unless you're like somehow have a special relationship, you it's not like I can call him or I know him or anything.
Yeah, right. Okay, so I feel like we've been keeping this big secret about e-textiles. Tell us what e-textiles are. What are some of the variations? Because I'm thinking there's fabrics that have sort of the circuits weaved into them, and then there's fabrics that have circuits stuck onto them. And what are they used for? Like, what are some of the different things that they're used for?
So e-textiles or electronic textiles are electronics that are woven into or meant to be attached to textiles. We've kind of started moving towards saying things like flexible electronics because the parts that we make are encapsulated in a polymer film. So when you hold it, it doesn't feel like a textile, but they are meant to be attached to different kinds of fabrics and like flexible surfaces is generally what they're meant to be attached to. And
Right.
yeah, I mean, I think that um, people hear the word textile and they get really attached to clothes and that like really quickly jumps to fashion. So there's like light up sweatshirts and this kind of stuff. But most of the applications that we work on are automotive and medical. We work on some consumer electronics as well. So they're mostly useful for places where traditional electronics are not flexible enough or not conformable enough. You might want a flexible electronic or like an e-textile, printed electronic, this kind of um, newer but growing field of electronics is all about like bringing new mechanical properties to electronics. And so the place where they make sense from a business standpoint is places where we're already using electronics. And generally what doesn't make sense is introducing them to places where there aren't already electronics. So yeah, a lot of what we work on is like there's a bunch of electronics in cars, there's a bunch of textile surfaces in cars, your steering wheel has a bunch of electronics wrapped inside of leather to give it sensing, to give it heating. Your seat has a bunch of electronics under the textile for occupancy sensing, for heating. For medical applications, I think it's taking more of traditional monitoring devices and making them more comfortable, making them softer by using e-textiles.
Okay.
Consumer electronics, it's more of things like cabling, pressure sensing, functions that just already exist. But for robotics, for example, sometimes traditional cabling doesn't want to bend and flex the way that you might need for something that has high mobility. If you use an e-textile or printed electronics, sometimes you can get better mechanics. So these are kind of the places and the customers that we tend to work on. Every once in a while, there's like a health and wellness smart shirt kind of application, but I think that those still really haven't they're happening in like very small volumes in the market.
Yeah, that actually makes a lot of sense because like I'm just wondering why, I don't have a crop top with a that's made from e-textiles or something like that. Is it that much of a leap to, I guess, manufacture and cost-wise and produce at scale to put e-textiles into our everyday clothing?
For this crop top example, what do you want the crop top to do?
Well, for example, I wear like a Garmin smartwatch, right? And I just always think I would love to free up my wrist to, wear a nice watch. But I still want to have, my sensors and things like that to track whatever, my temperature, my heart rate, all those sorts of things that the wearables currently track. It sounds like that could be a sensible application. I don't know.
Yeah, I mean, I think that I think that the problem with like a base layer tracking these functions is that unless you want to wear the same crop top every day or wash it every day, you'll need a lot of them. And they're really, this stuff is just still very expensive to make. So it's like, do you want to buy 7 of your Garmin smartwatch so that you don't have to wear the smartwatch?
Yeah,
And it's like,
okay.
you probably don't. I mean, maybe you do.
Because I was thinking because it's washable, you could just wash it. Right.
Yeah, but every day. Like if you have one, you'd have to wash it every day to get your data every day. Or I guess whenever it gets dirty.
Yeah. And I guess would that result in wear and tear on the electronic side of things, or
It's wear and tear on your clothes. that it just, your clothes aren't, they don't have this extra functionality. So oftentimes you don't notice, but I think it is obvious over some time that you'll notice your clothes start to just kind of look old. A lot of wear and tear comes from the washing machine. For these electronics, there's a lot of wear and tear. It really is, I think sometimes the like e-textile stuff, yeah, it really speaks to the imagination. But like, could you imagine being like, I'm
Yeah.
going to put this in the washing machine every day? Like your immediate reaction is like, oh no, like
No.
that seems kind of bad. It's the same kind of stuff we're asking for with being able to just toss these like smart garments in the washing machine. It's very difficult. I mean, I'm sure there's a way to make this washable if I encapsulate it and I
Yeah.
pat it, but it's not ideal. So it's a very difficult endeavor to make sure that the wear and tear allows the textile or allows the product to still function.
Right. So I guess it sounds like the technology just isn't there yet. We're just not at that stage where like it hasn't evolved to that stage yet.
I think I'm also in the space, so a little bit more biased, but I think it's just that the market doesn't demand it. The market doesn't want it. I think that like, with money, almost any problem can be solved. And so I think that, if they're just, if there's a
Yeah.
huge market who just wants to buy this crop top and they're ready to buy 7 for $300 each, and the only thing in the way is that it's difficult to wash the electronics, like it can be solved.
You
You
can
can solve,
solve.
but
Yeah.
the
Okay.
market just doesn't demand it, and it's difficult to do, and it's expensive. So that's my take, but I have a very
Interesting.
like biased view because we talk to as we customize our technology for different customers, so we talk to a lot of people building a lot of different things, and we talk to so many people who are like, I'm making a crop top, and then in 6 months, like, there's no crop top, there's it doesn't happen.
Really?
And I
Yeah.
think it's mostly that there's just like, it's difficult to build the business case for it.
Yeah, I guess the average person probably doesn't even, I mean, most people aren't still even wearing smartwatches. I guess only in the developed world is probably where you would see people wearing your smartwatches and so on. Yeah, if the demand's not there, it's probably not something you're going to spend your time trying to solve.
And I think that the demand and the volumes, like if your choice as a business owner, somebody who makes e-textiles, if you're like, for example, the the CIA put out this like $20 million grant for Department of Defense related smart garments, or
Yeah.
you can work with these auto companies, and they have like huge volumes. 50,000 units a year is small for them. And so, if you are developing a business, do you want to make the crop top, or do you want to do the military grant or the automotive? It's like the technology gets developed in the direction of whoever is demanding it, or whoever has the money basically to demand it. And it's not generally in the consumer space.
So does the military use a lot of this type of stuff?
Yeah, I mean, I don't know. I'm not sure what they use, but you can look it up. This is called Smarty Pants, and this is all for audio and
Oh, I think
video
I've heard of
monitoring.
that. So yeah, that's quite interesting. I knew that they were, like sort of on top of all the latest and greatest technology, of course, in defense, but I didn't know it was for audio and video monitoring. So in the textiles that you make, can you also produce outputs like that, like sound and haptics and things like that?
Yeah, you can. So it's still like, when you're assembling a printed circuit board, you have your traces, and then you have your components. And those components might be like a microcontroller or a sensor, range of different functionalities. And so similarly, we have our traces, which are soft and flexible. And for an output, like a vibration, haptic feedback, we attach a motor, like a linear actuator kind of standard motor. So I think sometimes there's this idea of like, you're making haptic feedback from fabric, and it's like, no, we use the same components.
No.
It's really just kind of like getting it all integrated into something that's soft and flexible instead of something that's rigid.
Yeah, that makes total sense. So for your fabric that heats up, how hot can you make it, and what do people typically use this for?
Sure. Yeah. So we normally try and stop somewhere around like 150 Fahrenheit. I mean, you can get a little hotter, but the laminations,
Okay.
like, yeah. So sometimes you can get some like there are different polymers involved in the part stack up, and those can start to melt and have some sort of degradation at higher temperatures. So, 150 Fahrenheit is generally a good temperature. And yeah, people like heating for outdoor products. There are already heated gloves and heated jackets on the market. So, of course, those are always nice. We do a lot of heating for automotive, especially with the emergence of electric vehicles. You run into this issue where it's more difficult to heat the cabin interior. So there's always interest for, different ways to heat the cabin interior. And then there are some industrial applications like pipe warming, or like hot supply chain heaters, those kinds of things, but we haven't gotten as much into that space yet.
Yeah, I'm thinking like heated car seats and things like that. Do you do a lot of that stuff?
Do some.
Wow, that is so cool. So I'm just curious, how did you stumble upon, you've got a number of patents for your fabric, well, textile. How did you stumble across this, this idea that was new and patentable and all that?
So I think one secret of, or at least like my experience, I'd be curious to hear like if you have experience with the patent office, but that there's generally something patentable if you like read existing patents and then find your little corner to carve out. And so I think that patenting has changed from what it was originally, where people were like really inventing all of these new incredible mechanisms. And I think now it's more of patenting like incremental improvements and sort of like small changes within a product manufacturing process, or the product functionality. So anyways, yeah, so I had been working on conductive inks in this space. We don't use conductive ink anymore. We don't at Lumia use conductive ink. Conductive inks are one of the most common ways of making soft and flexible electronics, soft or flexible electronics.
Yeah.
Printing them is very, very common. And there are lots of great ink companies out there who make these. We just kind of started there. And then, we worked with a patent attorney to sort of track everything along the way. So if you look at our patent portfolio, it starts with one big omnibus, which is basically like every idea we've ever had. And then you just kind of pull out separate pieces of that to represent what we're actually doing today. So it's kind of a less romantic story, but it really is that the patents, as a small business, having patents says, I know we're small, but you should still work with us because you can't get this somewhere else. So it really is kind of part of the business strategy that we have these patents, much less so than it is like you wake up one day and have an amazing invention and have to write it down. Or at least that's how it was for me.
Is that so? Are your patents like worldwide patents?
They're U.S. patents. We just started.
Okay.
We have pending global patents, so hopefully I'll be able to say worldwide in a year or two.
It's such a long process, isn't it? I find it extraordinarily long and painful.
Yes, and expensive. I mean, I think that's...
And expensive, yeah.
I think that's also one of the things that has sort of gotten away from the spirit of invention, is that if you actually do want a worldwide patent, you need that patent translated into every language for each patent office. And it's just super expensive. Like I think it's very difficult to get a worldwide patent as an individual inventor if you don't have like some serious financial backing, which I don't think was like the spirit of the patent office in the beginning. It's kind of like an individual should be able to protect their invention worldwide if they want, like an average person should be.
Yeah, and I guess with so many more people in this space. Well, actually, I don't know. Is it a busy space, the e-textiles industry?
Yeah, I mean, I think it is merging quite a lot with flexible electronics, which makes it a bigger, busier industry. Yeah, it's kind of hard to. There are some new players coming in, but it's not like AI or something where every day there's a new AI company and something.
Yeah, that is wild.
I think something that's also kind of unique about this space is that a lot of us kind of know each other. So, you go to conferences, you see a lot of familiar faces, you kind of know what people are doing in the space. When it comes to e-textiles, with like flexible electronics, I think it's just kind of bigger, broader, more established. But e-textiles, you kind of know a lot of the people working on things here.
Well, AI is just crazy busy and crowded, and I can't even keep up
Yeah.
anymore, honestly.
Yeah, we've seen so many hype cycles like since maybe 2012. I mean,
Yeah.
wearables had a moment, Bitcoin had a big moment, AI is having a moment. I'm curious what will happen.
BCIs,
Yeah.
they had a moment almost, well, probably 20 years ago, and then again recently, and then now. And I'm just wondering if now it's going to be the moment, but I sort of feel like it's not, because there's just still such a long way to go with clinical trials and all that.
Neuralink say that they passed some important clinical stage. I don't know exactly what happened.
Yeah, they just implanted their first patient with their device. So I think my understanding is that that's a test of both the device safety and also that of their surgical robot, which they used to implant the device. So yeah, that'll be interesting. Be interesting to see what comes out of that.
Do you have any opinions on Neuralink? I have like no opinions.
Neuralink?
I just know it exists.
Well, the thing is that Neuralink is like a year and a half behind the Australian company Synchron. I don't know if you've heard of them. Yeah, so they did their first in-person implantation in July 2022. So, and of course, the two companies have very different devices and different placement methods and so on. But yeah, of course, I'm rooting for the Australian company.
Yeah, I mean, it feels nice to root for something that's less of like a media scandal tied, marketing driven sort of project.
Yeah, and I think the whole method for that Synchron uses is very novel. So they've created a stentrode that goes into the blood vessels in your brain. So it comes up through the neck and it goes into your brain that way. So you don't need to cut your skull open or anything like that, which is, I think, a much safer procedure.
Yeah, I mean, I would imagine you still need surgery for the implant in your neck, but it's...
Yeah, I think it starts in your chest and then, it goes up through the vein that way. But cutting open the skull, exposing the blood-brain barrier is like a super risky procedure.
Yeah, interesting. It seems much smarter, I could imagine.
Yeah, I mean, it's interesting, but I mean, who knows where either of these groups, but there are so many players in this space now compared to, say, 3 years ago.
Really?
Yeah, when I started my PhD.
Pick up suddenly, do you think?
Definitely Elon Musk. Definitely Elon Musk and his and Neuralink. You know, Neuralink was always managing to raise so much money, but then we weren't seeing much progress out of them. But then I think off the back of all that marketing, all the raises, other smaller groups were able to kind of ride on that. And I think it's been good for the industry as a whole, you know?
Yeah, absolutely. It's like, I mean, that's kind of I don't want to say unfortunate, but I feel like that is sort of the mechanism of VC. It's very like trend and visibility based. And so, it seems like a good outcome that if Neuralink can make it trendier, then other companies can raise money and developed product.
Speaking of large, giant companies, you've worked for a ton of big names. Are you able to share with us some of the stuff you've worked on?
Yeah, I can only share things when they're out in the public. For Adidas, I just did a workshop for them. So I visited them in Germany, it was just a small workshop that we did together. But for some of the builds, I can only share them once they're out in the public, which
Right.
unfortunately they're not yet.
That's what I was thinking. But what about the sock that you made? Did you do a sock with Mississippi State University?
Yeah, that's a project that they were working on. So basically, what we make components. So we made them an interconnect bus attached to a series of pressure sensors for their sock, and they attached it and then programmed it. But we kind of make these little parts. So we made this part that goes onto the sock, and then they ran some trials. I think that I have to see what the latest is in terms of where it is now. But that was at least one that we could share because it was a research oriented.
I mean, that's pretty cool. I've seen a lot of new research coming out in the way of footwear, like shoes, socks, all that sort of stuff.
Yeah, what kind of things have you seen?
I know for cerebral palsy, they're doing a sensor in a shoe to look at gait and things like that, or improvement of gait with treatment. A lot of it's in the medical space. There isn't much in sort of just the non-medical space. I guess probably comes down to what you were saying before, which is there isn't the demand there. But I think a lot of these things are so useful for things like research, and probably not beyond research.
Yeah, I think they're really, I agree. I think that they're super useful for research, really useful for people who require long-term monitoring, who have, I think there's, Sensoria makes a smart sock to help avoid diabetic amputations, monitor small changes in temperature. In order to help you avoid getting too far down the line. I think that things like that are also extremely useful, where it's you have a health condition, you're trying to avoid the worst possible outcome. And yeah, that's that I think I was talking to a friend about it, and I have to remember the words that she used, but I think she was saying it's preventative monitoring, something where it's the outcome that you're trying to avoid with long-term monitoring. And I think that that's really different than just kind of wanting to monitor for the sake of it because it's interesting, because that's going to help you overcome the barrier. If you're I have to buy 10 of these socks, which my insurance will pay for, so that I don't have to get my foot amputated. You're I will wear the sock. I will hand wash it if I have to. And I think that that's sort of where these business cases and use cases come together, because it's cost is covered by insurance. They also want to avoid the surgery that's super expensive. The customer is super incentivized to wear this thing that won't feel like a normal sock because it's not. They're incentivized to take care of it. And therefore, there's a company that's incentivized to build it. And then it all comes together very nicely. So yes, these medical research applications are, I think that is where a lot of development can grow.
And I think it's probably also easier to justify testing that product as well, because I imagine a ton of testing has to go down. Is that your experience?
Yes, there's so much testing, and I think that that's something that I think sometimes when I tell people I work on e-textiles, their immediate gut reaction is oh, you should work with Zara, or something like that. And it's Zara doesn't test any of their products. It's actually a completely different product development cycle.
Yeah.
They make a thing and then they just throw it out in the market, and there's no risk, there's no danger. And with these materials, it's they are electronics. You need FCC to legally sell them in the US. You want UL certification or some kind of third-party safety testing to avoid a critical failure and hurting someone down the line. If you want to sell it in Europe, you need CE certification, and all of these tests are expensive and time consuming. And only make sense if you're like, this is a medical device, or this is like this is mission critical to our company. This is what our company does. And yeah, it's like Zara does not do that. They sell other stuff. So
with varying degrees of quality, I have to say.
yeah.
What's like the typical time frame for testing? Like, is it months? Is it weeks? Or does it depend on the
It
product?
depends on the product, but I think like it also depends a lot on in-house facilities. So because we work with industries, we work with a wide range of industries. And what that means is that we can't do every test that a customer wants in-house. Like there's a test in automotive called ingress egress, which is basically like a giant robot. They attach like a butt wearing jeans to a giant robot, and it like has to sit and like turn on your material
No way.
hundreds of thousands of times. And if it fails, it will not work in a seat. And it's like, we don't have the giant robot to do this. So the testing can take running that test actually takes days, because it takes so much time to repeat all of these cycles with the robot. But if you don't have it, then you have to like get in line to run your test, or you have to get the customer to run the test, and all that can take, weeks, months, trying to get in line for some of these machines. So yeah, if you have like a wonderland of machinery, you could run things in days, but half the battle is just like getting the machine to run the test.
I always forget about those repetitive testing robot things.
Yeah, they're super cool, but it does take time.
They're so cool. Whoever came up with them is like, it's like, what made you think of that?
Done before. I feel like there's probably some like heavy guy in the office wearing jeans, and they're like, okay, Jim,
Yeah.
you gotta sit here. And when you get tired, you
And
gotta
wiggle.
around.
You never think about what we did before all this advanced tech came along.
It must have been so much harder. I mean, I think that we do live in like a heyday of making physical things, because you can send someone a CAD file and get a part CNC machined on a lathe and sent back to you in 2 weeks or something. And it's like, before that, you have to like sketch it out, add dimensions, go down to your mill, tell them about it. They had to like, I don't even know, I guess it's done by hand, and then they measure and try and do it again.
It's kind of cool. Like, I wonder what it would have been like to live back then as well.
Or like, you hear these stories of entrepreneurs from back then, not even that long ago, but they would be like, I was the first person to like open up trade in the Orient, or these like very outdated things where it's like nobody traded with China, just like you did not. Now everything we buy is like, well, maybe it's changing now, but it's like so much of it is from China. It's like 100 years ago, it's like you did not manufacture there. And somebody had to go and be like, hi, I'm from X country, let's make some stuff together.
And they would have been like, what?
It's crazy.
Yeah, and you didn't have any translators or anything. Like, you wouldn't have spoken each other's language. Yeah, I can't imagine. You must have had to have been so adventurous. Like, we probably think we're adventurous now, but I can just imagine back then the level of risk taking that you'd have to be open to.
I love that you said adventurous, because it makes it, I think so much we think of business as like spoiled people in suits, but I think that there was this side of it, like you were saying, where you had to be like down for the adventure. You're like, maybe this will work, maybe it won't. I was speaking with a woman who has this like automotive consulting company, and she was like, yeah, we didn't have Google Maps, so I went to Japan. I'm in the train station. I have this like printed out map of where I'm supposed to go, and all those signs are in Japanese, and I'm just like, maybe I'll get there. Maybe I won't. We'll see.
Yeah, you must have had to have just like a really open mind, like whatever happens, happens.
Yeah, I think so. I think that that's a very like impressive and exciting spirit that, it's not Now it's like the last frontier is kind of actual nature adventure. There's not as much, business adventure
Oh, yeah.
in the same way.
Totally. Even people that take business risks, I feel the business risk is not that risky. Like, there's always something to fall back on in most cases. But I don't know, was that the case with you? Like, did you set up your company, Lumia, during the fellowship or after the fellowship? What was sort of that timeline
Yeah,
for
I mean, I
you?
set it up when I started the fellowship. I didn't know what it was yet. I just, I think a lot of that there are kind of like two ways to go after something. And you can, choose a recipe and go buy the ingredients for this thing that you're going to cook. Or you can see what you have in your fridge and be like, I will make a meal from the stuff that I have already available. And I definitely made more of this. I will make a meal from what is put in front of me, where there was somebody tied to the fellowship who was like helping people incorporate for a warrant. And, even incorporating can be kind of complicated. For like a C corporation, you have to set up a board, you have to set up different shareholders, you have to like buy there's all this stuff that you need to do. So I was like, okay, well, if he'll help me set it up, then I guess I'm incorporating. It was kind of that spirit. Of course, that's not what you should do necessarily, but that's sort of how I approached a
Yeah,
lot
it
of
sounds so
things.
complicated in the US.
Yeah, but what is it like in Australia?
It's pretty straightforward. Like, you can just buy a company, pay for it, and that's it. You're done. You sign the papers, you assign the directors. But if you start to grow and get to a certain size, I think a lot of people will start creating a board of directors and things like what you said. Did you fundraise? Did you get investors?
We did get investment, yeah, and this was also sort of the what's in my fridge approach, where so I had done this residency at Autodesk. I'd worked on conductive inks, and it was kind of like the heyday of where like Google had just done Project Jacquard. People were kind of excited about the space. And I had two people who had previously run the fellowship. They were starting a fund, and they're like, if you want to turn this into a business, we'll invest in you. And I was like, well, okay, I will do that. I had the corporate structure already set up, but I was just doing consulting projects. It wasn't like a product focused sort of business, the kind that you can get like investment for. So yeah, I was like, okay, sounds good. That's what I'm doing now. So that's what started the process in a lot of ways.
So you didn't really have to like go around and pitch to VCs or any of that. You have
me like yeah, it's interesting because again, like I feel like I've learned so much, and I also feel like I was so naive when I got started. I also didn't really know how much money, because I think like I kind of felt like I was going to do it anyways. It's like whether I get $10 or whether I get $1 million, I'm going to do this anyways. So it's hard to draw that line where you're like, I'm going to go get $2 million or whatever it may be. And so I like went around and just talked to a bunch of investors, and some of them invested, some of them didn't, but we ended up getting more funding. And then we just like continually talked to investors for years, which is also not how you're supposed to do it. You're supposed to sort of have these like, like we got the money rounds. Yes, we didn't do that. We just like kept talking. We kept getting money kind of like trickling in slowly. And then, yeah, now we really don't anymore. I think there's kind of, yeah, it's like we can mostly run our business from customers. So it's like we really use that money for product development to have something to offer customers. Now we can mostly get our income from customers. So we focus more on that.
That's awesome. It's only been what, like 7 or 8 years?
Yeah, I mean, since I incorporated in 2014, it's been 10 years, which is crazy. Chop it up into pieces. It's like, okay, the first 2 years were just like projects. Then 2016, we got some money. Then we spent the next like 5 years actually making 4 or 5 years making the product, getting it scalable, getting it tested. Then COVID came, and then now we're on the other side. So it sounds like a really long time.
You survived COVID.
I mean, yes, we made it through COVID, and we're definitely impacted. One of the big projects we were supposed to do in 2020 was for an aerospace company. They make planes. They were signing and they're like, we have a payment freeze.
No.
We're like, no. Now we're somewhat on the other side.
Yeah, totally. Oh, that's awesome. It sounds like you have that, whatever happens kind of attitude, which is, I think, just probably the best way to go about it and, remain positive.
Oh, thanks. It's definitely not always, I don't, I was actually thinking about this a lot the other day, where I think that there's a specific outcome that I want. And it's kind of like, no matter what, I will do everything I can to reach that outcome. So if something happens that day, that's not what I wanted, or, if we don't raise the full round, whatever it is, it's like, I will find another way to reach that outcome. So it's sort of like whatever happens on a day-to-day basis, but long term, it's like, I only want one thing to happen. Whether it will or not, we don't know.
Yeah.
But I'll try.
Well, we're engineers. We'll find a way to reach that outcome.
Yeah,
right?
You have to be persistent. I mean, I feel like a PhD is just kind of all about persistence because it's so long.
Oh yeah, during my PhD, I'm finished now, and looking back, I just go, oh my gosh, like what was that? And I did mine during COVID, so everything was impacted. We were supposed to work with the hospital, collect data from patients. The hospitals were closed down, everyone were in lockdown. Everything just went belly up, and I had to pivot a lot. But I made it out the other side. So yeah, I think, you just keep finding new creative ways to approach things or to look at things. And I think you can find a way around almost any hurdle, right?
Yeah, I think so. I mean, it's not easy, but it's like where there's a will, there's a way sort of philosophy.
What would you say is like one of the biggest challenges that you faced along the way?
Yeah, I mean, there have been so many of them. I feel like I've been trying to choose one that's nice for, not nice, but like good for public consumption.
Yeah. That's mild.
Yeah. I think that, and it's like more of a broader thing, but I think one of the challenges is constantly being sort of stretched. It's like this actually comes very full circle to our conversation, where it's like at the beginning I had to learn how to fundraise and how to pitch to people, which is not like, I'm not like an extroverted person. It's like not what I want to be doing. And you kind of have to like stretch yourself because you're like, I'm gonna just do it even though I don't want to be doing it. And I feel like I'm not even good at it. You just kind of like stretch yourself a little bit. I got my degree later, so there's just a lot of stuff I didn't know about hardware and physical product development. So we were kind of learning everything along the way, which made things a lot slower. Like I didn't know a lot of these testing methods. I didn't know I didn't have any connections to like source materials, all this kind of stuff. So you get stretched because you're like, okay, I'm just gonna figure out how to do this and how to use these programs and figure out what to do. And then there's the whole management side where you're like, I'm going to learn how to manage people and like stretch in that direction, right? Figure that out. And then now we're in more of a marketing phase of the company where we're like, okay, our systems are working, our team is working. We want, we got to put ourselves out there more. We need to get our customer acquisition funnel really streamlined. And of course you can go and like hire someone to help you with all these things. But I personally have a very hard time assessing someone if I have no idea what they're doing. If I'm just like, you do it, I think that never works out. You kind of need to like try it on and get it in your bones a little bit. And then you can go and hire someone and actually assess if you're aligned and if you think it will go well. But that requires some stretching because it's like, okay, well now, what is it like to think like a marketer? What do they do? What do they care about? What works on LinkedIn? All these kinds of questions. So yeah, I feel like the hard part has been constantly needing to stretch because it's very fun and nice to feel like you're competent and good at something. And it just does not feel like that most of the time. So
Yeah, all those businessy things are so different to like the engineering things that we just do in the lab or, in our little room, and all the experiments. Those are fun. And then you got to go out and talk to people, and it's like, ah.
and it's so different. I mean, also, I feel like if you're talking about research, you can kind of rely a little bit on the outcome and just be like, we did this experiment. The outcome was this. Anybody have questions? Like, this is just the hard facts. And it's so much harder when it comes to these very like fuzzy things like storytelling and, convincing negotiating.
Oh,
I'm
I
like, I don't,
know. Yeah.
how do I know if this story's
Yeah.
working? It's just, yeah, it feels very unclear.
It's like, oh, yeah, this story's interesting to me. Is it interesting to you?
Never are.
Yeah, the whole storytelling piece is, I find it, quite esoteric, I think. It's interesting that you mentioned the degree that you say you didn't have the degree till later. You went back and finished your degree. Do you feel like that helped you? Because I don't know, a lot of people, I think, especially engineers these days, are in this phase of like, I don't need to go to uni or college. I can learn everything online. I can build at home. I can teach myself. Do you think degrees are still helpful? Like for people wanting to go into engineering type roles or businesses?
It's very, I found it to be very helpful. And I think like most of my knowledge on how to physically build something and make something comes from working. But what I learned in my classes was much more about assessing information and being a diligent thinker, which I think were both things I was lacking and are actually very important if you want to make high quality decisions and you want to do high quality work. So I find it to be very, very valuable. It helped me think a lot better. And I learned some, there are like some practical equations that you learn. You're like, great, maybe I'll use those. But I think it was very formative in making me a more like diligent, serious person, which I think is important.
Serious?
Serious.
No.
I guess serious in the sense of this word comes to mind because there's that line in Succession where he's like, you all are not serious people, because his children are never really that occupied with what's actually going on, and they're very occupied with like, what will I get? What do they think? What do you think? What did you say? And I feel like, that's what I mean in terms of seriousness. It's like being occupied and focused on the problems at hand rather than with kind of like, unnecessary excess, like mental confusion or drama.
Yeah, like all the
Yeah.
noise. Yeah, I think that's actually what I found, in my degrees, in my PhD, that critical thinking piece, like assessing information, structuring it, thinking creatively but within constraints, is probably one of the most useful things I know I've gotten out of it. Yeah, I think nothing beats the practical work, the hands-on stuff.
Yeah. Well, what made you decide to go for your PhD? What drove the decision?
Oh gosh, so many things. I always wanted to be in healthcare, and I actually worked in fintech for some time. And, I was like, finance is not me, banking is not me. And I worked there because it was a nice, stable job. I had my son to look after, and I did my degree on the side. Like I did it while I was working there, my undergrad and my honors year. And then I went to work in a clinic for a year, and that was when I discovered a lot more of biomedical engineering stuff, like the EEG, electroencephalography, looking at the brain with, MRIs, all that neuroimaging tech. And I was just like, I have to know more about this. And that was really what it was. But also, I wanted to understand the healthcare system here better. I'd had some really bad experiences in my family with the healthcare system, and I really wanted to understand why there were bottlenecks. Like, why was it so hard to find a good GP? Why is research so slow to reach people? And it was never my dream to stay in academia or anything like that, but I did want to work directly with doctors. I wanted to work in the hospital system. I wanted to work with other patients as well and learn what their experience and what their journey was. And I got to do all of that. So I kind of achieved what I set out to do, I guess.
Yeah, I think that's great. It sounds like curiosity really drove you. And I think that's a very powerful thing. It's not just like, it's not like it would be a good thing to do, sort of. It's like, no, I just have to know more.
Yeah, like a lot of people just fall into it after their honors year. They'll have a lecturer, they'll be like, oh, why don't you do a PhD? And they'll just do it without any particular reason sometimes. I think sometimes for some people, I mean, I'm sure it works out great for some people, but I think it's better if you do decide to commit to a PhD, because it's a long journey, that there's like a really good reason behind it, because it can get really tough, especially in that second year and third year. You're just like, oh my God, I wish this was over.
What sort of helped you power through? Was it this idea of like, I still want to learn more?
You know what? I just felt like I'd already done so much work that I couldn't. I always felt like I was just so close to, so close to getting a publication or so close to finding something, that I think it was really that. And also I'd committed to it. I'd won a scholarship for it. So, yeah, I felt like to not finish it would be almost like giving up. And I don't know, but I don't do that. So yeah, I think that was really what it was.
Yeah, that kind of persistence, just wanting to finish what you started. What was it like with yours? I mean, maybe your son was a little bit older, but what was it like sort of balancing your son and PhD?
Oh my gosh. So when COVID started, which was a year in, it was crazy because we were in lockdowns. I was homeschooling him. I was also teaching myself machine learning, programming. I didn't know how to program. I taught myself all of that. I was learning about epilepsy, which is what my PhD is focused in, and then also helping him with his homework. And it was just like, it was actually such a wild time. Like, I have just these core memories of being up at like 1 a.m. fixing bugs in my code. Like,
It must have been so overwhelming. I can't, because also that's so, like, teaching yourself something is so physically, like, mentally taxing that it's not just willpower. It's like, my brain is tired. I can't keep, like, learning stuff. I can't keep functioning. Yeah, it's really difficult.
And I mean, I was fortunate. I had some lovely colleagues in the lab who helped me out initially. But you know what? People do get tired of helping out after some time. And then, there was a lot of tutorials and stuff. I think, I was just like, I have to finish this. I have to push through. And luckily, I got a publication in the second year, and I think that kind of gave me just that little boost that was like, okay, we're getting there.
Yeah, you're getting there. I feel like all of us need this little, like, you're getting there message along the way.
That little you're getting there moment. Yeah, it's true. I've never really reflected on it that way. I just wanted to ask one last thing. What advice would you give to anyone starting out or entering your industry?
I mean, I think I would tell them to find out where there's developed work around this industry and see what they're hiring for, and then learn those skills and apply for those skills. And if you want to start your own thing, that's different. But actually, like, Meta is hiring a ton of people in e-textiles, which is awesome.
Oh, really? What for?
For their virtual reality stuff. They post job postings for it all the time. And I know a bunch of people from e-textiles who went there. So, and there's also some other like soft goods, technical soft goods companies who hire. So yeah, I would say like find these little pockets where really cool companies are hiring, see what skills they want, learn those skills, and work there, because I think that's where like a lot of great work and interesting ideas are coming.
Yeah, and I suppose working in those, well, yeah, small companies or big companies would give you a really nice skill set and experience. Like, do you think that experience is the most helpful?
I think so, because so much of this stuff is very mechanical and trial by fire based, for better, for there's still questions like which test, like there's a ATCC test, which is the American Association of Textile Chemists and Colorists. They controlled all of the washing tests until E-textiles came along. Because
What?
every washing test was like, does your garment change color or shrink in the wash? Like those are the questions. But now e-textiles are asking, does it change resistance in the wash? So how do you, like, do you make a new standard? Do you use their standard and modify, which is a lot of what people do? Do you use this new standard from IPC, which is an electronics agency? But most people with washing machines like don't run this IPC standard yet. So if you just work in a company, you can kind of get these answers into your bones and be like, I use this standard modified this way, or I do this, I do that. And I think that helps you, because a lot of this stuff is still being understood.
Yeah, interesting. So what's next for Lumia? I know you mentioned the marketing piece. Are you looking to expand outside of the US? What's next on the cards for you?
With companies in Germany fairly frequently. A lot of our customers are kind of like global companies, so we might work with their German office, for example. But what is next? I am thinking about new kinds of, we focus on e-textiles, but I would love to work on a new material. And I don't know what it is yet. And it's still really early. And, who knows what will happen. But I'm thinking about, new material opportunities. So that's what's next.
And you'll have to find time in between being stretched in all the different directions.
Luckily, I feel like this is the place where it's not stretching. Like this is the fun spot. So there's a risk I may not stretch in the different directions because this stuff is more fun. Like,
imagine if you just came out with some new textile that no one ever heard of.
Yeah, I would love if we could make it happen. So I think we'll try.
Yeah, that would be so cool. Well, good luck with that. And thank you so much for your time. I cannot wait to see what you do next.
Yeah,
Thank
thanks
you.
a lot.